let me just prove what I stated just a minute ago. That setting marginal revenue equal to marginal cost is equivalent to satisfying the first order conditions for profit maximization. Profit is revenue minus cost. And let's assume that we can express both revenue and costs in terms of output. So then our profit function in terms of output is just revenue, R of Q, minus C of Q. We know the first order condition for profit maximization is that pi prime of Q equal to 0. But notice that pi prime of Q here, from this equation right here, is R prime of Q minus C prime of Q. That's just the sum difference rule of differentiation. Pi prime of Q is R prime of Q minus C prime of Q. And the first order condition is that this be equal to 0. So let's take this equation here. R prime of Q minus C prime of Q equals 0. Bring this C prime of Q over to the right, and we get this. R prime of Q equals C prime of Q. Marginal revenue equals marginal cost. So marginal revenue equals marginal cost is equivalent to the first order condition for profit maximization. Okay. Now the second order sufficient condition for a maximum is that the second derivative be negative. So what is pi double prime of Q? Well, pi double prime of Q is just this, R double prime of Q minus C double prime of Q. And the second order sufficient condition for a maximum is that this be negative. Okay. Now, in words, what is R double prime of Q? Well, let me back up. What is R prime of Q? Ryan, what is R prime of Q?
The rate of change of profit is Q.
R prime of Q. Okay, so it's the derivative of revenue with respect to output. R prime of Q is just the derivative of revenue with respect to output. Or, in economic terminology, R prime of Q is marginal revenue. By definition, it's marginal revenue. So, what is R double prime of Q then? And let me back up. Geometrically, what is R prime of Q? Okay, the slope of the revenue function. Okay. All right. What about R double prime of Q then? Okay. What that tells you, if R prime of Q is marginal revenue, then R double prime of Q is the slope of marginal revenue. Okay. R prime of Q is marginal revenue, so R double prime of Q is just the slope of marginal revenue. And in a similar fashion, C prime of Q is marginal cost. C double prime of Q is just the slope of marginal cost. So the second order sufficient condition here requires that the slope of marginal revenue minus the slope of marginal cost be negative. Now generally, the slope of the marginal revenue curve will be what? Negative. Generally, it'll be negative. And generally, the slope of the marginal cost curve will be, greater than or equal to 0. In our example, it was actually 0. but generally it's going to be 0 or positive. So if the marginal revenue curve has a negative slope, then we'll be okay. As long as this thing is greater than or equal to 0, you'll have 2 negative terms there. And that guarantees that the second order condition for a maximum will be satisfied. Okay. Or in other words, what you need is the marginal revenue curve to cross the marginal cost curve from above. Notice in this case, the marginal revenue curve looks like this, and it's crossing the marginal cost curve from above. Okay, so that guarantees that the second order condition will be satisfied. In this example here, notice the slope of marginal revenue is negative. The slope of marginal cost is 0. So you have a negative here and a 0 here, so it's satisfied. Okay. The only case where the second order condition wouldn't be satisfied is if you had a funny case like this. Suppose we have a peculiar marginal revenue curve that looks like this. So this marginal revenue curve, initially, it's downward sloping. But then there's a stretch here where it rises, then it peaks and then falls. Notice in this case, if you had a marginal cost curve that looked like this, marginal revenue would equal marginal cost at 3 places. Here, here, and here. And let's label these 3 points, A, B, C. Which of these points would represent maximum profit? Which would represent minimum profit? C would be a maximum. At point C, notice the marginal revenue curve has a negative slope. The marginal cost curve is 0. So C would be a maximum profit. What about A? No, A would be this point right here.
No, I mean, it's in the middle as far as profit.
Oh, okay. What would it be, a maximum or minimum, though? It would also be a max. Because at this point A, the marginal revenue curve has a negative slope. Marginal cost has a 0 slope. So this would be a maximum. But what about this point right here? Point B? Minimum. Because there, the marginal revenue curve actually has a positive slope. So the second pi double prime would actually be positive there. So if you had an interesting problem like this, you would have to compare profits at A and C and see which one of those generated the higher profits. You know the profit maximum wouldn't be at point B. That's actually a profit minimum at point B, if you look at the second order conditions. Okay. All right. Actually, you're wondering why I'm going on about this? Actually, I wrote a paper on this many years ago with a couple of colleagues that were at UNCG. And, what's interesting about this problem is the marginal revenue curve in this problem actually has a positive slope. And it is possible to have marginal revenue curves that have a positive slope in a certain region. So that is a possibility. Okay. And that gives rise to the possibility of having multiple profit equilibria.